Okay, so there's this clearly growing need for high-performance embedding inference. That's the process, right? Generating these embeddings from new data.
That's the one.
So what does this really mean for us day to day? And what can these models actually do in the real world beyond just, better search and recommendations?
Well, it's fascinating how foundational these models are becoming. For almost any practical AI application you can think of, really, they're often the silent enablers behind experiences we now just sort of expect,
Like what?
like a hugely improved search relevance.
Hmm.
Instead of just keyword matching, they understand the meaning behind your query and the documents. So you get way more accurate results, even across like massive databases.
So no more wading through pages of useless results just because one word matched. That's a huge time saver right there.
It really is. And they're also the engine behind those hyper-personalized content recommendations you see everywhere. Shopping sites, streaming services, music apps.
They figure out your taste.
Exactly. By understanding your preferences, your history, and matching that to the characteristics of the content, they tailor the whole experience. And in finance, embedding models are critical for advanced fraud detection.
Oh, so.
They can spot really subtle anomalies, complex patterns in transaction data that, frankly, a human or simpler algorithm would probably just miss completely.
Wow. That's a massive win for security and peace of mind, I guess.
Absolutely. And inside companies, they help with intelligent knowledge management, making it much easier to find information, connect dots, foster collaboration, even if you have just vast amounts of internal documents and data.
Okay.
And maybe the most exciting part, they're essential for building truly smart AI agents and automation tools. Agents that can understand really nuanced requests, automate complex tasks, provide context-aware help in customer service, operations, tech support, you name it.
It seems pretty clear then for any of this stuff to really work well that inference part, making the embeddings, has to be super fast, incredibly accurate, and ultimately affordable, right?
Couldn't have said it better.
Because if it's slow, the user gets frustrated. If it's full of errors, the whole system gives you garbage results or worse.
Exactly. The whole thing falls apart.
Now, here's where things get really interesting, or maybe a little frustrating for companies trying to implement this stuff today. The sources we looked at really highlight some big challenges with the existing ways of doing embedding inference, saying that, the traditional engines often just fall short, especially now with Gen AI needing so much more.
That's spot on. Buddy Ecosystem, just through their own work trying to build things, they uncovered some really critical limitations with the common solutions out there. One of the most, frankly, alarming findings was just the incredibly high error rates, particularly when dealing with longer inputs.
Longer inputs. What do you mean by that? And why is that such a big deal for Gen AI stuff?
That's a great question. Think about trying to understand, say, an entire legal contract, or analyze a full customer support transcript, back and forth, or even just understand a complicated piece of software code.
Right, you need the whole context.
Right. Precisely. Gen AI models often need to process a lot of information all at once to really get the full picture. That's what context length refers to, how much text, how many tokens the model can handle simultaneously. Being able to handle these long inputs is absolutely crucial for many real-world tasks.
Okay.
But popular inference engines, like Hugging Face's Text Embeddings Inference, or TEI, it showed a shocking 94% error rate when dealing with these higher context lengths. We're talking 8,000 tokens here.
Wait. 94% error rate. That's not just slightly off. That's almost always wrong.
Yeah.
That's like your customer service bot recommending your competitors 94% of the time. Or your fraud system missing basically all the fraud.
It makes it essentially unusable for anything serious, you're right.
Mm-hmm.
And Infinity Inference Engine, another one, wasn't dramatically better. It showed a 37% error rate under the same conditions. Still way too high.
So basically unusable for production where you actually need things to work reliably.
Completely unsuitable, yes. And beyond just the accuracy nightmare, they also found significant performance bottlenecks. Many existing engines just struggle to keep up. Latency gets too high, throughput drops, especially with bigger models or lots of users hitting it at once.
Right.
And that really hobbles real-time applications. It kills scalability. Imagine your AI agent taking so long to respond that customers just hang up. Or your recommendation engine lagging so badly it's irrelevant by the time it loads.
Yeah, performance issues aren't just an annoyance. They directly hit the business, the bottom line.
Precisely. And then there were critical stability problems, too. Their testing showed that TEI reportedly just crashed fell over completely when the input context length hit 16,000 tokens.
Crash, so the whole service just stops.
Yep. Major service disruptions, which cost businesses time, money, reputation. And finally, there's just the cost factor. These older systems can be really inefficient with resources, often needing expensive, specialized hardware, which drives up the operational costs of running these models at scale. It makes it really hard for companies to actually get the full benefit of Gen AI.
Wow. Okay. So it really sounds like the market is just screaming for a new approach, a new generation of inference engines built specifically to tackle these fundamental problems: accuracy, speed, stability, and cost.
That's exactly the gap that needed filling.
Okay, let's unpack this then. Bud Latent. This is Bud Ecosystem's answer, you said. Engineered specifically for production-ready inference, focusing on performance, accuracy, cost efficiency. So what makes it different? Tell us about it.
Well, Bud Latent really does seem to be a significant step up. First off, stability. Unlike TEI, which, as we mentioned, could just crash at higher context lengths, Bud Latent showed really robust stability in testing. That means uninterrupted service, even when things get demanding.
Okay, crucial for production.
Absolutely. It's designed ground up for production environments. Things like multi-cloud support, multi-hardware support, horizontal scaling, auto-scaling, plus comprehensive monitoring and tracing tools built right in.
So it's not just like a cool tech demo, it's built for the real world, ready for serious workloads.
That's the idea. And what's also really impressive is its versatility. It's not just about generating embeddings. It can handle re-ranking models, too.
Re-ranking?
Yeah, like taking initial search results and reordering them for even better relevance. It also does text curation, intelligent prompt routing, deciding which AI model is best for a specific incoming query.
Ah, smart.
And it handles multimodal and cross-modal applications. Think text and images together, and even text classification. It's designed as more of a unified inference solution.
That sounds really comprehensive.
And they've tried to make deployment easier, too. There's this zero configuration feature using something called the Bud Simulator. It basically figures out the best deployment settings for you automatically, and an automated hardware sizing and finder tool that helps identify the right hardware across different clouds, finding that sweet spot between performance and cost.
Okay, that sounds like it could remove a ton of the usual IT headaches and guesswork involved in setting this stuff up.
That's the goal. It also offers really flexible deployment options: cloud, on-prem, bring your own cloud, BYOC, even client-side deployments in some cases.
Wow.
And this flexibility, combined with being able to deploy heterogeneous clusters, meaning using different types of hardware together across 16 different cloud platforms, that directly tackles those hardware supply chain issues everyone's facing, gives you options for scalability and cost savings.
That's huge right now. And what about efficiency?
Yeah, for peak efficiency, it supports advanced precision formats like INT8 and FP8 on various types of hardware.
Okay, hold on. INT8, FP8. For listeners maybe not deep in the hardware weeds, what does that actually mean? Why is that good?
Good question. Think of it like using smaller numbers to do the math where possible. Instead of using, say, 32 bits of data to represent every number in the calculation, INT8 and FP8 use just 8 bits.
Okay.
This makes the calculations much faster and uses significantly less memory. And the key is, for many parts of these AI models, you can do this without really losing accuracy. So there's a massive win for speed and efficiency: less power, less cost, faster results.
Got it. Faster, leaner math.
Exactly, and it supports multimodal stuff too. Text, image, audio embeddings all handled seamlessly. Plus, the ability to run multiple different models at the same time on the same instance, which is crucial for complex AI apps juggling different tasks or data types.
Okay, so we have this really advanced software, Bud Latent, built for speed, accuracy, reliability. What happens when you pair it with powerful, widely available hardware like, say, Intel Xeon processors? Where's the synergy there?
That's where it gets really compelling, connecting it back to the infrastructure. Benchmark results show that Bud Latent running on Intel Xeon processors significantly outperforms the other solutions we talked about.
How significantly?
We're talking up to 90% faster than TEI and up to 85% faster than Infinity in terms of raw inference speed.
Wow, 90% faster.
Yeah, and that translates directly into much lower latency for the user and much higher throughput, meaning it can handle more requests per second. Specifically on Intel Xeon, the test showed a solid 1.4x performance boost compared to TEI running on the same hardware.
That's a massive jump. Users would feel that immediately in responsiveness.
They absolutely would. But, as you said earlier, speed isn't everything if it's not accurate.
Right. 94% error rate problem.
Exactly. But Latent, on the other hand, achieved an error rate of less than 1% at that same 8,000 token context length.
Less than 1%, compared to 94% and 37%.
Precisely. It's a night and day difference. That kind of accuracy gives you the reliability and trustworthiness that mission-critical applications absolutely demand. Businesses can actually trust the results they're getting.
Okay, so it's not just fast, it's reliably accurate. How does it manage that, especially working with the Intel Xeon processors? Is there specific optimization happening?
Yes, absolutely. Bud Latent is deeply optimized to really leverage the features built into Intel Xeon processors. For instance, it makes heavy use of Intel AVX and AMX instructions.
Okay, technical terms again. What do AVX and AMX do?
Think of them as like special super fast lanes on the processor's highway. They allow the chip to perform many calculations simultaneously in parallel. It's crucial for the kind of math these AI models do.
So more work done at the same time.
Exactly. But Latent also uses custom-optimized software kernels specifically tuned for Xeon, and it features something called NUMA node awareness.
NUMA node awareness. What magic is that?
It's all about memory access efficiency. Modern servers often have memory banks that are physically closer to some processor cores than others. And NUMA awareness means the software makes sure the processor grabs data from the closest, fastest memory bank available.
Minimizing travel time for the data.
Basically, yeah. It might sound small, but at scale, shaving off those tiny delays really adds up and makes operations much more efficient. So it's squeezing every last drop of performance out of the hardware architecture.
Okay.
So the combined benefits really stack up. You get a very compelling price-performance ratio, leveraging the widespread availability and cost-effectiveness of Intel Xeon processors. You get genuine production-ready reliability because both the hardware and Bud Latent software are built for stability. And you get excellent scalability, allowing businesses to potentially use the CPU infrastructure they already have, maybe reducing the need for super expensive specialized accelerator cards.
That last point is huge. Using existing infrastructure more effectively. So this raises the big so what question for you, our listener. What does all this performance, this accuracy, this stability really mean for how businesses can actually use Gen AI? What kind of potential does this unlock?
Yeah, this combination really does unlock significant potential across the board. Take AI agents, for example. Companies can now build genuinely high-performance, production-ready agents. Agents they can rely on with that less than 1% error rate to automate complex workflows in customer service, internal operations, tech support. Imagine the efficiency gains, the smoother customer journeys.
That sounds like a definite game changer for both customer satisfaction and just internal productivity. A lot less frustration all around.
It absolutely is.
Yeah.
Then think about enterprise search and knowledge management. This kind of performance accelerates finding information across even the biggest document stores, making internal knowledge instantly accessible, not buried somewhere. In financial services, it means much stronger real-time anomaly detection and risk analysis, making fraud detection more robust, more proactive, catching things earlier.
Okay.
In healthcare and life sciences, faster similarity searches across huge biomedical data sets that can genuinely speed up medical research, help improve diagnostics, and back to e-commerce and personalization, recommendation engines can become way more dynamic, delivering truly user-specific content that feels almost intuitive, really helpful.